Good afternoon. I'm JP Chang, Director at KOSHA, Smart Occupational Safety and Health Technology Institute. I'm very grateful to have the opportunity to make a presentation at OAIC 2023. Though we still have a long way to go, I'm going to share with you the constant chemicals monitoring system. This system has been under development since 2020 and is now in test operation. The order of presentation is as follows: background, composition and function, test operation cases, and implications. Before I move on to the main discussion, I'd like to briefly introduce KOSHA. KOSHA means Korea Occupational Safety and Health Agency. KOSHA was established in 1987 and is composed of headquarters, 4 institutes, and several area offices. We especially focus on the industry types with frequent fatal accidents. We carry out patrol inspections to prevent falls in construction and cut in or cut between injuries at manufacturing sites. Now, let me begin with the background. The Safety and Health at the Heart of the Future of Work report published in 2019 by ILO. So technology, demographics, sustainable development, and changes in work organization. These changes seen as the future challenges and opportunities of OSH. The report says digitalization and ICT technology development can provide opportunities to remove risk environment by monitoring the exposure to risk in real time. Therefore, a paradigm shift is necessary to protect workers' health by using ICT technology. Though Industry 4.0 technology keeps developing, it is not being applied to and used in systems for industrial accident prevention in Korea. While these technologies are being actively used in other areas of safety, such as firefighting safety and public security, OSH is applied with just conventional technical guidance and facility and equipment improvement. As a result, cases of acute chemical poisoning with chemicals are increasing in Korea. Most cases have occurred during non-routine work, temporary or short-time cleaning work. For example, there was a death caused by acute poisoning with dichloromethane last year. Also, a person died while cleaning inside a TCE washing tank in 2019. Although Korea has devised a work environment measurement framework and provided technical guidance to prevent such acute poisoning accidents, these measures are not enough to prevent accidents caused by non-routine work. That is because the work environment is measured semi-annually, and the technical guidance is given just as a one-time visit for technical support. In addition, business owners have a complacent mindset that there is no problem as long as they comply with the basic law. And this results in a lack of motivation to improve the work environment. So, I need to introduce a constant real-time exposure measurement method to make up for limitations. How can you regularly monitor chemicals exposure and actively respond to high-risk situations at work site to prevent acute poisoning accidents involving chemicals? In order to make up for such a limitation, we have developed the constant chemicals monitoring system with a combination of sensor and IoT technology. The picture on the left is a remote sensor developed in 2020, and on the right side is another one developed in 2021. From now on, I would like to elaborate on the composition and function of the constant chemicals monitoring system using IoT. The constant chemicals monitoring system is developed to regularly monitor the exposure concentration of chemicals by installing IoT-based remote sensor at the business establishment that handles chemicals and enable the businesses to control the work environment by itself by analyzing and using the data on the monitoring platform. I would like to show you an animation video to help you better understand the monitoring system. The slide shows the flow chart of the system. Step 1. With the sensors installed at the business sites, the measured data is transmitted to a monitoring platform where workers or managers can check the exposure concentration of chemicals in real time. Step 2. When the exposure goes above a certain level, an alarm is triggered in the sensor and the SMS notification is sent to registered mobile phones. Step 3. With this system, businesses can check the performance of ventilators and improve the work environment to prevent occupational disease. Also, if a business submits an application to our KOSHA, we provide support with consulting services and funds for work environment improvement. The remote sensors were developed in 2020 to measure TVOC, hydrogen fluoride, hydrogen cyanide, and chlorine gas respectively. In other words, you can use a sensor with a TVOC detector if you want to measure TVOC. A separate LTE router is attached to the sensor for communication. The remote sensor developed in 2021 supplemented what falls short of the 2020 version. The new sensors are modular and they can be attached to and detached from the device. This allows TVOC, carbon dioxide, temperature, and humidity to be measured at the same time. Communication parts were also upgraded with an LTE router embedded for automatic connection. PID sensor is used for the device as it was the most appropriate to detect TVOC according to our research. PID sensor used the principle that the UV rays generated in the UV lamp detect a material with an ionization tendency if it is below a certain electron volt. Its measuring range is 0 to 6,000 ppm and its response time is 3 seconds. The picture on the left is a PID sensor. The concentration value of certain chemicals can be estimated by multiplying its response factor RF, which is provided by the sensor manufacturer, and the TVOC value detected by the PID sensor. For instance, when calculating the exposure concentration of TCE, if the TVOC value detected by the sensor is 10 ppm, it is multiplied by 0.6 of the TCE's RF to estimate the TCE's exposure concentration to be 6 ppm. Chemical manufacturer provides the RF of each chemicals as seen in the table below. There are about 700 RF values for 10.6 electron volt sensors. The standard for alerting signal was set on the basis of the ceiling value provided by ACGIH. If a chemical doesn't have a ceiling value, it is set on the basis of the value 5 times of TWA. When alert is triggered, immediate response such as ventilating or wearing PPE, can be made on the ground. Users who received an SMS notification can promptly check the risk level in a remote environment. This video shows how an alert is triggered when the chemicals in the atmosphere is above a certain level. When the alarm rings, an immediate ventilation necessary message pops up on the LCD screen. Let's watch the video. For your information, chemical spray in the video is hand sanitizer. The exposure concentration of chemicals detected by a remote sensor can be checked on the connected platform. The data can be seen with both on a PC and a mobile phone. The data can be used for self-safety management of business establishment. Below are screenshots of our platform in operation. Let me share some test operation cases. The constant chemicals monitoring system was installed at business establishments that handle TC for test operations between May and December 2021. In establishment A, where a local exhaust ventilation system is normally operating, the daily maximum and average exposure concentrations are below the alert level. If we look at the real-time data over day, with the highest maximum exposure, the value was temporarily high during the time when chemicals were used. In establishment B, where a local exhaust ventilation system is automatically turned on only during working hours, the daily maximum and average exposure concentrations are above the alert level. But it is ironic if we see the data of a day with the highest maximum exposure. The establishment uses a system where TCE is automatically injected to wash the pipes 24/7. As soon as the ventilation system stops working around 8 p.m., the TC concentration rapidly increased and was maintained in the washing room. And it dramatically dropped when the ventilation fan was turned on around 7 a.m. Such a trend was recognized throughout the establishment with the installation of sensors. We instructed them to prohibit entrance to the site unless it is ventilated. If necessary, enter the site only after turning on the ventilator from the outside. Lastly, I would like to talk about the plans and the implications of chemicals monitoring system. We started the development of a low power and small size personal exposure sensor in cooperation with a startup. If successful, the sensor will run wirelessly for more than a year, have no restriction for installation, and enable the detection of exposure concentration of chemicals for each individual. For businesses with the high risk of acute chemical poisoning, such as cleaning chemicals, we will help them in connection with our project. Furthermore, we will partner with the private institutions to distribute the constant chemicals monitoring system to small and medium-sized businesses. In the mid and long term, we will stabilize the system by 2027 and institutionalize the system by 2030 to encourage its distribution among business establishments. I believe the constant chemicals monitoring system will be an opportunity to shift the paradigm of exposure measurement for occupational health. According to the law, work environment measurement is conducted twice a year, And this measurement estimates the exposure by the value detected on the day of measurement. In contrast, our monitoring system always monitors chemical exposure, which makes the system more meaningful. Moreover, it presents a new direction for chemicals management, where the exposure level is monitored remotely and regularly using Industry 4.0 technologies such as sensors and IoT. This will allow businesses to establish a system that can control the exposure concentration of chemicals on their own. This concludes my presentation. If you have any questions, I would appreciate it if you could send it to me via email. Thank you for listening.